Okay, the question 10 is similar to the non-homogeneous system. Okay, video YouTube that you watched just now. You have, okay, this is, okay, network circuit where the left side you have the voltage, okay, 100 sin 2t volt, and we have one inductor with L equal to 1 Henry. Middle you have here R2, which is 2 ohm, and the left loops you have the bottom, we have another one R1 equal to 3 ohm. At the right loops you have a resistor C equal to 0.25 farads, okay, and you have bottom R3 is 3 ohms. Let's denote the current flows in the left loop is I1, flow is I2, the right loop is I2. If the question asks you to show, then only you show it. If not, some of the question, this question they ask you to show that the network circuit can be moderate, then only you need to show it. Otherwise, you can straight away solve it. Okay, like if this one probe, again you have to probe. Some questions, like question 7, the network circuit in figure question 7 here can be modeled by the following system of first order differential equation. They didn't ask you to show, so you can straight away solve for this non-homogeneous system. Because the question straight away evaluate the general solution for homogeneous system. So depends on the questions. If they didn't ask you to show that the application of the network circuit can be modeled as a non-homogeneous system or homogeneous system, then you no need to show, you can directly solve it. Question 10, because the question wants you to show. Paste in the PDF. I'm having problem to write in words. I'm using very long tail. Suddenly, the tablet having problem with the Microsoft Word, so I couldn't write. I can write, but you will hate it. So, see, very. If I write here, will you hate it or not? Very long tail. This is a question 10 of tutorial 4. Okay, first part of the question, I ask you to shows that this network circuit can be modeled as a non-homogeneous system. So first of all, okay, if we focus on the left loops. Okay, if I focus on the left loops.
Ma'am?
Yes.
Sorry for the late time. My line is just 2 words I was trying from just now. No, hemorrhage.
Later on. I think the attendance your attendance later on the TikTok already closed.
Right.
Okay, so this is a tutorial 4. You can get it from the author. Okay, question 10 of tutorial. Given this network circuit, first part, with question A, they ask you to shows that this network circuit can be modeled as this one. This non-homogeneous system. So I'm going to demonstrate here how you model it. Exactly similar to the YouTube that I asked you to watch. So you focus on left loop first. Then on the left loops, you have this is voltage across the inductor. So you have the VL plus voltage across the VR2 equal to the supply voltage, which is the ET. And the difference here, left loops, the currents we indicate by I1, and right loops here, I2. Because I1, we break it into I1 and I2. So left loop is I1, right loop is I2, where I1 and I2 are actually in the anti-clockwise directions. So VL is actually current I1. So you have L d I1 dt. For R2, I1 is anti-clockwise, we indicate positive, and then for I2, up to here, this one opposite direction, so it will be negative. So for VR2, we have I1 minus I2 multiplied by R2 equal to ET. We plug in L is 1, so you have dI1 dt. So R2 is 2, so you have 2 I1 minus I2. ET given here is 100 sin 2t. So we want to form a non-homogeneous system. So notice the left hand side you have dI1 dt, and then it brings 2I1 minus 2I2 to right side, so minus 2I1, so plus 2I2 plus 100 sin 2t. So you can check if you already obtained the first 55 plus 2.
What's that? How about R1?
Still got one more at the bottom. R1, 3. You're right. That's why missing. The answer here, the first term here, in the matrix, A11 is negative 5. You're right. Missing one more term. Yeah, you still have here, the bottom. So I put in the red color. Okay, this one, I miss out here. This one. So plus, R1 is only I1, because in left loop is only I1, only at R2 you have I1, I2 opposite direction. So plus I1 multiplies your R1. So this one plus R1 is 3, so 3I1. So 2I1 plus 3I1, positive 5I1 bring to right side. Okay, so total is negative 5. This is negative 5. Okay, 2I1 plus 3I1. At the left side, you have positive 5I1. Bring to right hand side, so become negative 5I1. Okay, at the left side, this is minus 2I2. Bring to right hand side, so become positive 2I2. Okay, that's why you get, yeah. So this one, if you read back, okay, I1 prime is actually, I couldn't write in word. Okay, I1 dt. In first row is actually di1 dt. Okay, when you, okay, some of you may confuse how you do it. This one is, okay, this is a matrix 2 times 2. This is 2 times 1. So the result is a 2 by 1 matrix. 2 by 1 matrix where you take the first row times first column with negative 5 times I1 plus 2 times I2. Negative 5 I1 plus 2 I2 plus 100 sin 2t, which is here. di1 dt equal to negative 5 I1 plus 2 I2 plus 100 sin 2t. Okay, this is the first equation. And now you focus on the right loop. Right loop, okay. Right loop, we have the VC. Okay, plus VR3. Okay, so I will use this method VC plus VR3 equal to VR2. Equal to VR2. VL, okay, VL plus VR2. Okay, for VL plus VR2 plus VR1 equal to ET. Okay, now you let VC plus VR3 equal to R2. So VC you have, okay, 1 over C integral I. Okay, I flows through the capacitor is I2. So this is I2 dt. Okay, VR3 also is I2. So you have the, okay, I2 R3. Okay, VR2 is here. I1 minus I2 times R2. So plug in the R, okay, R2, R3 and C value. Okay, C is 1 over 0.25. So integral I dt. R3 is 3. So 3 I2. So R2 is 2. So 2 I1 minus I2. Okay, 1 over 0.25 is actually, we have here, one over 0.25 is actually 1 over 1 over 4, which is become 4. So this one you have 4 integral I dt plus 3 I2 equal to 2 times of I1 minus I2. Okay, to eliminate the integral I dt, you ddt go hand side. Then you ddt for ddt integral I dt plus 3 times, okay, ddt I2, you get di2 dt equal to 2 times, this is di1 dt minus di2 dt. Okay. So ddt integral I dt, you get only, this is I2, I2. So 4 I2, 3 di2, okay, right hand side is minus 2 di2 dt, collect with the left hand side, the 3 di2 dt, so total is 5 di2 dt equal to 2 times di1 dt. Okay, and then you plug in di1 dt, plug in here. So your 5 times di2 dt. Okay, 4i2 bring to right side is minus 4i2 plus 2 times di1 dt that we obtained just now, negative 5i1, negative 5i1, and then plus 2i2 plus 100 sin 2t notice here, this negative 4i2, 2 times 2 you have positive 4i2, so mean cancel. So you just get negative 10i1, negative 10i1, i2 cancel, negative 4i2, 2 times 2, positive 4i2 cancel each other. So you have negative 10i1 plus 100 sin 2t. So this is 5 times of di2 dt. So we want 1 time of di2 dt to divide by 5 at both hand side. So we have negative 2i1 plus.
Doctor.
Yes.
100 or 200?
Oh, 200. Yeah. 2 times here. 2 times 100. So be careful when bracket. Sometimes we forgot to multiply. Expand it. So it's 200. 200 divided by 5. 200 divided by 5, so we have 40 sin 2t. So now we got two equation. One is di1 dt, another one is di2 dt. So you put it into the matrix form where you have di1 dt, di2 dt. And then let me put it here. Negative 5i1, 2i2. So we put into the form of, actually we put like the form of I prime equal to ai plus g, where a is your 2 by 2 matrix. How to get the 2 by 2 matrix? Get out the coefficient for your i1, i2. So negative 5, 2 for the first row. Negative 5, 2. Second equation, the coefficient for I1 is negative 2. Coefficient for I2, we don't have I2, so it's 0. So this is I1, I2. When you expand back, exactly, when you take first row times this one, you have negative 5. And you must keep familiar with your matrix multiplication. When you multiply matrix, you have negative 5 times I1 plus 2 times I2. So second one is when take second row time, first column you get second row first column, which is negative 2 I1, 0 I2. And then we have the vector G exactly. Second equation is 40 sin 2t. First equation is 100. 100 sin 2t. 100 sin 2t. So the assistant of this vector G make it become non-homogeneous system. So negative 5, 2, negative 2, 0. I do this 100 sin 2t, 40 sin 2t. So we have moderate it. So this will become di1 dt. Let's say we indicate as I prime A. Your matrix A is 2 by 2, negative 5, 2, negative 2, 0. If we got two first order differential equation, then your matrix A is 2 by 2. And your vector I prime is 2 by 1. I here is 2 by 1. Your vector G also 2 by 1. If you have three first order differential equation, then your matrix A will be 3 by 3. your I prime, you have 3 by 1. I here also I1, I2, I3. Vector G is 3 by 1. So now we have this non-homogeneous system. To solve that non-homogeneous system, okay, as what you have learned, you have to solve the homogeneous system first. So with your solution, okay, first step, solve the homogeneous system. Right. So you solve step 1 is actually solve homogeneous system. To solve homogeneous system, you have 3 steps. Okay? Step 1A is find the eigenvalue. Later on, find the eigenvector V1. Okay? Third step, find the eigenvector V2. So repeat one more time. Okay, so step 1A, you want to find your lambda 1, lambda 2 eigenvalue. So how to find the eigenvalue? To find the eigenvalue, you let the determinant of your A minus lambda I equal to 0. Okay, the matrix A. Okay, what's the matrix A just now? Negative 5. Negative 5 to negative 2, 0. Negative 5, this negative 2, this is 0, this is 2. So this one is minus with lambda, is minus with lambda. Okay, determinant, so it's a straight. Equal to 0. Negative 5 to negative 2, 0. Okay, so anyone have problem to find the eigenvalue or not? Negative 5 minus lambda. 0 minus lambda is negative 8 lambda. So minus the product of the other diagonal. So this is minus 4. So minus negative 4. So be careful when you find the determinant. Okay, if we put here negative 4, later on we have different eigenvalue. So expand carefully, you have this to be 5 lambda plus lambda squared plus 4 equal to 0. So you have lambda plus 1, lambda plus 4 equal to 0. So mean your lambda 1 equal to negative 4, lambda 2 equal to negative 1. Okay, you have obtained lambda 1 and lambda 2. So the step 1b here, find the eigenvector V1. Okay, to find eigenvector V1, you solve the system A minus lambda 1 I V1 equal to 0. Okay, A minus lambda I V1, okay, from this determinant, you change it to round bracket, substitute a lambda 1, which is negative 4. Then you have here negative 5 minus negative 4. This is 2. It's negative 2. So minus, okay, the lambda 1 is negative 4. 0 minus lambda. V1, let it equal to x and y. Simplify it. Okay, negative 5 plus 4, you have negative 1. So this negative 2. So this is positive 4. Then xy equal to 0. Okay, you notice that in second row, I divide by 2. Second row, I divide by 2. Put back to second row. So no changes on your row 1. So second row divide by 2. So negative 2 divide by 2, you have negative 1. 4 divide by 2, you get 2. So x, y equal to 0. First case, you see row 1 is actually equivalent to row 2 are actually the same. Mean 2 unknown, you just left to one equation which is negative x plus 2y equal to 0. Again, you see here, negative 1 times x plus 2 times 1. It's basically make use of matrix multiplication, rows times columns. So negative x plus 2y equal to 0. So x will be equal to 2y. If you let y equal to s, x will be 2s. And we have xy. So x is 2, y is 1, s. So your v1 will be 2, 1. Check the answers. Correct. See the answer here. Yep, this is actually A, this is V1. Exponent negative 4t. This part is actually your IC. Okay, this part is actually the IP. So it obtains a V1 already. Okay, any question before it proceed to the V2? Or do you want to try? To find V2 is similar. You just need to replace your lambda 1 here by lambda 2. So the process is the same. Step 1C. You want to find V2. To find V2, solve your A minus lambda 2 I V2 equal to 0. Okay. So basically you can start from here. Same with step 1B, you just replace your lambda 1 here by lambda 2. So negative 5. Negative 5. Okay, lambda 2 is negative 1. This is 2. This is negative 2. Okay, this is minus lambda because this entry value is 0. So lambda is negative 1. V2 also we let it equal to xy. So equal to 0. Simplify it, you will get this is negative 5 plus 1. So negative 4. This is negative 2. This is 2. This is positive 1. And then xy equal to 0. You notice if row 1 you divide by 2, row 1 divide by 2, put back into row 1. No changes on your row 2. So row 1 divide by 2, you get negative 4 divide by 2, you get 2. 2 divide by 2, you get 1. So no changes on your row 2. So again, you can see row 1 is actually equal to your row 1 equivalent to row 2. It means 2 unknown, but you left to only one equation, which is negative 2x plus y equal to 0. That's why you got infinite many solutions. So in this case, y equal to 2x. So we let x equal to s, y will be equal to 2s. Then you have this is x, y. X is 1, y is 2, so s. Okay, letting s equal to 1, you obtain your V2 is actually 1, 2. Okay, put up your, into your, this is IC. IC, you have A, V1, exponent lambda 1 t plus B, V2, exponent lambda 2 t. V1, okay, V1 is 1. V1 is 2, 1. V1 we got 2, 1. Lambda 1 is negative 4. So plus B. V2 is 1, 2. Lambda 2 is negative 1, T. So this is your IC. Complementary functions for your homogeneous system. Okay, this part. Now we are going to find the IP. Okay. Okay. Using undetermined of coefficient, you choose IP same form with your GT. So now step 2. Step 2, find IP. So we choose KIP. This one we use undetermined of coefficients. Coefficients. Choose the IP based on GT. GT you have 100 sin 2t. 100 sin 2t, 40 sin 2t. Then the IP similar to second order differential equations, second order non-homogeneous differential equation. If you have a sin or cos, then the IP also must be in terms of linear combination of sin and cos. Since the IC we already use a variable A and B, here I'm going to use C, D. So sin, same pattern, this sin 2t, so here must be sin 2t, CD, and then EF, cos 2t. Okay. We choose IP based on GT. GT is at the, here, this one. Your second order non-homogeneous equation, you choose the IP based on the right hand side function, the fx or ft, or your IP. After you choose the IP, you have to check whether the IP clash with your IC. So in this case, is it clash? IP is sin, in terms of sin 2t, cos 2t, but IC is exponent negative 4t, this is exponent negative t. Is it clash or not? Clash or
No,
not?
madam.
Yeah.
No.
Not clash. If clash, you have to, I think, clash, they should multiply by t. So this case, not clash. If not clash, then you can straight away differentiate one time only. Because your system is I prime equal to AI plus G, where the I is replaced by IP. So you want I prime, so you have to differentiate your IP to get I prime. So in this case, you just differentiate one time, but in second order non-homogeneous equation, you need to differentiate it two times. So you differentiate only one time, IP prime, differentiate sin 2t, where C, D, E, F are constant. Differentiate sin 2t, we got two times, okay? So 2c, 2d, got two times. Cos 2t. Differentiate cos, we have negative. So negative 2e, 2f, sin 2t. So this is a IP prime, this is IP. So you are going to plug in into your I prime equal to AI plus G. So mean IP prime you plug in here. IP, then you plug in. So now we plug in left side. You have 2c 2d cos 2t minus 2e, 2f, sin 2t. This is left hand side. Okay. Matrix A. Go back the question, the matrix A. Matrix A. Negative 5, 2, negative 2, 0. Negative 5, 2, negative 2, 0. Negative 5, 2, negative 2, 0. Okay, I replaced by the replaced by the IP that we choose. I replaced by IP. Where you have CD sin 2t plus EF cos 2t. In A, you have to multiply this one, and then you multiply this one, plus G. G is actually, you have what? Okay, 100 sin 2t, and then this is 40 sin 2t. 140. Okay. So you may expand the right hand side first. In left hand side, you just copy it down. 2c, 2d. This is cos 2t minus, you got 2e, 2f. This is sin 2t equal to, the metric A times, I do it slowly, negative 5, 2, negative 2, 0. Okay, this one multiply CD sin 2t. Okay, plus, we expand the metric A. Because your I here, you have two terms. One is sin 2t, another one is cos 2t. So A you times with the sin 2t term, later on plus with A, metric A times with the cos 2t term. So you have negative 5, this is 2, negative 2, 0, with A times with the cos 2t term, EF cos 2t, add up with your G. G is 100 sin 2t plus 40 sin 2t. Okay, and then, so now you use your metric multiplication techniques. Okay, this is a 2 by 2. Mean A is a 2 by 2. This vector is 2 by 1. Because sin 2t you can put it inside. So this is a vector 2 by 1. So the column in the first matrix equal to the number of rows in the second matrix. So these two matrices can be multiplied. The result will be 2 by 1. Mean 2 rows, 1 column only. And then how you multiply a matrix? Takes 1 row times 1 column. So negative 5 times C plus 2 times D. Negative 5C plus 2D. Okay, this is for sin 2t. So I collect with this one. So 100 sin 2t. Okay, later on, it takes a second row. Second row times first column. So you get here, second row, first column. Negative 2 times C. This 0 times D. You have only negative 2C. Okay, collect, because this is sin 2t, this is also sin 2t. So plus 40 sin 2t. And then you do, okay, now the second term. Okay, doing this term now. Doing this one. Negative 5. Take this one, multiply this one. So negative 5e plus 2f. This for cos 2t term. Okay, and take the second row. Here, your second row times first column. So you have negative 2e. Cos here is only sin 2t term. You don't have cos 2t term. So cos 2t is only negative 5 times e plus 2 times f. First for first row, second row is negative 2 times e plus 0 times f. So it's negative 2e cos 2t. For sin 2t, exactly, you will see the red color, row times column. Negative 5 times c plus 2 times d, collect with 100. Because this we collect all the sin 2t term. For second row, negative 2 times c, this is 0 times d plus 40. So now you can compare left side, right side. Okay, left side you have actually 2c, 2d, this is cos 2t minus 2e, 2f sin 2t. Because we are going to solve for 4 unknown, which will have 4 equations, C, D, E, F. We are going to determine C, D, E, F. So, okay, if I compare cos 2t, compare the cos 2t term. So, we have 2c, 2d, 2c, 2d, cos 2t, okay, cos 2t equal to negative 5e plus 2f is minus 2e. Okay. Then if I compare the sin 2t term, okay, left side I have negative 2e, negative 2e, negative 2f. Right hand side is here equal to negative 5c plus 2d plus 100 minus 2c plus 40. So you have 1, 2, 3, 4, total 4 equations. So you can solve that 4 equations simultaneously. You'll get A, B, C, D. Here, put out the 4 equations first nicely. 2c. In the first equation, you have what? 2c. Okay. First equation, 2c, you don't have d, so plus 0d. Minus, okay, right hand side is minus 5e plus 2f. I collect everything to left hand side, so plus 5e minus 2f equal to 0. And from here, cos 2t term, 2c, don't have d, so 0d. Okay, right side is negative 5e, bring to right side, so positive 5e. This positive 2f, bring to left side, become negative 2f. And then the second equation from cos 2t, here you have d, you don't have c. So 0c plus 2d, e at the right hand side, bring to left side, so plus 2e, don't have f, so plus 0f equal to 0, because we don't have constant. Okay, the third equation from sin 2t, okay, first here, so negative 5c plus 2d, okay, I bring to left side, so become positive 5c minus 2d minus 2e, don't have f, so 0f equal to 100. Okay, positive 5c is minus 2d, okay, minus 2e, don't have f, so 0f equal to 100. The fourth equation from the second row of sin 2t, okay, negative 2c at the right side, you bring to left side, so you have 2c, positive 2c, okay, this is 40, don't have d, so plus 0d, e don't have, plus 0e, minus 2f equal to 40. Okay, I'm going to use a scientific calculator to get the solution quickly. Okay, only this model you can solve 4 simultaneous equations. For the ES, MS, you can solve up to 3 simultaneous equations only. So I just need to key in the coefficients. in the calculator, here I already arranged nicely C, D, E, F. So my C is tallied with X, D is a Y, Z is my E, and here I should have one more variable, T is a F. So I just key in the coefficients. 2, 0, 5, negative 2, right side 0, and then second equation 0, 2, 2, 0, 0. Okay, third equation 5, negative 2, negative 2, 0, 100. The fourth equation 2, 0, 0, negative 2, 40. I'm going to check it. Okay, I'm going to check my right hand side 0, 0, 140. Okay, the coefficient for F negative 2, 0, 0, negative 2, correct. Coefficient for E 5, 2, negative 2, 0, 5, 2, negative 2, 0. Coefficient for my D 0, 2, 0, 2, negative 2, 0, correct. Coefficient for my C is 2, 0, 5, 2. Okay, everything correct. Okay, then I just press. Okay, I get X is 20. Okay, X is actually my C. From the calculator, I obtain C is 20. Y is 8. Y is my D. D equal to 8. And then Z equal to negative 8. Z is my E. So E equal to negative 8. T is my F. F equal to 0. F equal to 0. Okay, plug in the value of A, B, C, D. It means C, D, E, F. C is 20, D is 8. So C, D, this is a coefficient for sin 2t. This is actually my IP. E, F. E is negative 8, F is 0. So this is a cos 2t. C 28, negative 8, 0. 28, negative 8, 0. So this is a IP. And then the general solutions is actually you have the IC plus IP. In the I is actually IC plus IP. So the I just now we have A. One is already A 2 1 1 2. A 2 1 exponent negative 4t plus B 1 2 exponent negative t. Your IP, okay, so obtained here 28. This is sin 2t plus negative 8 0 cos 2t. So this is a general solution. Up to here. Find the general solution to that. This is a non-homogeneous system using method of undetermined coefficients. So if you want to find particular solution, they must give you the initial solution, initial condition. And to get particular solution, they must provide you, let's say, t equal to 0, okay, and then what is the I1? I1 equal to what value? And then your I2 equal to what value? And you plug in. Okay, I here is actually solving for I1, I2. So you plug in what's I1 value, what's I2 value. Okay, when t 0. So exponent 0 is 1, exponent 0 is 1, and then sin 0 is 0, cos 0 is 1. Okay, let's say, I'm sure, let's say, I just plug in. Okay, let's say given when t0, I1, when t0, let's say I1 is 1, I2 is 1. Okay, then plug in 1, 1. Then you get this is A, 2, 1. Cos exponent 0, you get 1. And plus B, 1, 2. Okay, sin 0, you got 0. This term got. Cos 0 is 1. So you have like here, negative 8, 0. Okay. Then you change it to the system of linear equation form. You have actually here 2A plus B equal, okay, this one negative 8 collect to the constant term. So 1 plus negative 8 is collect together. So you plus x, so will be 9. Second row, you have A plus 2B. A plus 2B. This one 0. So the second row, you're only left here 1. Okay, so you can quickly solve these two simultaneous equations using your scientific calculator. Question works here. Simultaneous equation now is 2. So key in the coefficient for A and B. So it will be x and y in the calculator. 2, 1, 9. And then 1, 2, 1. So I get x is actually the A, 17 over 3. A is 17 over 3. And then the B is actually the y, negative 7 over 3. The B is negative 7 over 3. So plug in A and B, you obtain the particular solution. So means your I1, I2 is actually A is here 17 over 3 to 1 exponent negative 40, B is negative 7 over 3. That 1, 2, exponent negative t plus 28 sin 2t plus negative 8, 0 cos 2t. So this is particular solution. Okay, be careful. Some of you will tend to plug in the initial condition in IC, but it is wrong. You cannot plug in the initial condition into the IC to obtain A and B, because IC is only the homogeneous system. So if you plug in the initial condition here, it's wrong because your system is non-homogeneous system. So for non-homogeneous system, you must get the solution for a non-homogeneous system which consists of IC and IP. Then only you plug in the initial condition to here. Because the answer for A and B you plug in into here, or the IC is totally different. You plug in into A and B, mean initial condition T0, I1 is 1, I2 is 1. That one is actually the particular solution for your homogeneous system. Okay, and this one I forgot to say, if the ET here, if you don't have the voltage here, normally you'll get the homogeneous system. If you don't have the voltage, you'll get the homogeneous system. Right. Expression. Right here. Like this case, question 2, figure question 2, without the voltage, okay, you get only the homogeneous system. So we just managed to solve question 10.